It takes me close to 3 minutes to read this list of 67 different chemicals, including 5 E numbers, benzene, which is linked to acute leukemia, bone marrow abnormalities, and cardiovascular disease, acetone, concentrated nail polish remover, and formaldehyde, which is described as highly toxic for all animals, and where a 30 milliliter solution containing only 40% formaldehyde is enough to kill a grown human. Many of us eat the ingredient containing all these chemicals almost every day. What you would definitely call a natural ingredient. I'll tell you what it is soon, but first I have to complain a little bit about the word natural, because the word natural really annoys me. And when you think of it, what does it really mean anyway? What is natural and what is not natural? Isn't really everything we do as humans natural? When we build cities and pump up oil, isn't that natural in our nature to do? Or is it only natural if we live in caves made by Mother Nature herself? In making fire isn't even natural. Where is this line between natural and unnatural? I don't think you can find such a line. Still, there are many who have this clever idea that natural is the better choice. And very often when there's talk about health, natural is viewed as good, whilst the unnatural synthetic stuff is less good. And if you can't pronounce the name of something, well then you should definitely stay away. And this is not okay. We actually have to deal with this misconception. And therefore, I'm here on stage as a really boring physicist, bothering you with physics and chemistry class, and I know that you were all having such a good time. I'm sorry in advance. Okay, so there are some things that, yes, they are good for us, and stuff that are not good for us. Really, really bad for us. But we don't find the answer in natural versus unnatural. So I made a little list to try to emphasize this. So the sun. The sun is, I guess you can call the sun natural. If anything is natural, it must be the sun, right? The sun may give you serious sunburn, and with time it may give you cancer. None of which are really good for you, but they're really natural processes, right? On the other hand, it will make you produce vitamin D, which is good for you. And as a nuclear physicist myself, I of course think it's really cool. The sun is a continuously exploding atomic bomb, and all the energy that we get here on Earth actually comes from nuclear power. Natural. Sunscreen. Well, I guess that sunscreen is more on the less natural. Maybe you would call it unnatural, I don't know. But if you're planning on spending some time in the sun, I would say it's really stupid not to put it on your skin. Water. Yes, water is natural and really good for you if you drink it. As long as you don't drink too much and overdose, you may actually die. And also, water is not good if you inhale it. Glasses. Well, not so natural, I don't know. But I still think they're a pretty good idea. Radon gas, 100% natural. It comes from the ground, from thorium and uranium, and with the right doses, it may cause lung cancer. 100% natural lung cancer, that is. I guess that's better than unnatural lung cancer. Uranium. Uranium is very natural, and it's a heavy metal and slightly radioactive, and not the first thing I'd eat. Planes. Yeah, I guess you can say that it's unnatural for people to fly, even though we only apply the laws of physics and nature to achieve it. Chlorine is natural and deadly. The thing is that nature simply is. And what I mean by that? Well, nature does not care why something happens. And nature does not have memory. Hydrogen and oxygen that has met and formed a water molecule simply is water. There's absolutely no difference whether the water molecule was made in a lab or if Mother Nature made it herself. And if you're a homeopath and you shake the water in a very special way, the water molecule still has no memory and still is simply water. And that's exactly how it is for all other types of molecules as well. Who made them does not matter. Of course, that doesn't mean that it's indifferent whether you eat a carrot or you take pills containing beta-carotene. And a lot of young girls, they take pills containing beta-carotene because the skin will be a little bit more brown, or actually more orange, but they do this. And well, the thing is that it's of course not the same as eating carrots, and the reason is that, well, carrots contain more than just beta-carotene. So we have to be careful to compare what kind of comparisons we make. We have to compare apples to apples and not apples to pears, or carrots to just one singular chemical. And by the way, if you could make a pill containing all nutrition in a carrot, I would still choose to eat carrots over taking that pill, because I like to eat, not because pills are unnatural. So now we have to talk a little bit more about chemistry, because hand in hand, or maybe as an extension of this natural is good argument, you also find this. In this product, you'll actually find this element, and I've heard this element is bad, therefore this product is bad too, logic. Yes, an example of that is the people who say that there's mercury in vaccines. No, there's never been mercury in vaccines. There has been a molecule containing mercury atoms. Maybe some of you now think that, well, I'm a little bit picky, right? I mean, if there's a molecule with mercury atoms, then there's mercury in the vaccine, right? No, that's not right. And I will explain this with this super short introduction to chemistry. Okay, one. Everything is made up from atoms, hydrogen, oxygen, carbon, sodium, chlorine, gold, mercury, uranium. So far, we know of 118 different ones. 2, if you combine 2 or more atoms, you get a molecule, like the water molecule. And 3, if you only have one type of atoms, you get an element, like hydrogen gas. 4, and now comes the important part. If you combine different atoms, you get a chemical compound. And when you make a chemical compound, the properties of the atoms often change radically. That's important. And 5, a chemical is a common term for both elements and chemical compounds. So if you want to live in a world without chemicals, you actually don't want to live, and you don't want the world to exist either. And that's just the way it is. End of discussion. Okay, so sodium chloride and H2O are 2 really great examples of chemical compounds. We all know them as regular salt and water. They are made up from sodium and chlorine and hydrogen and oxygen. And sodium and chlorine, they're really dangerous as pure elements. Deadly, actually. And hydrogen and oxygen, I mean, they're extremely unsuitable to put out a fire if you look at either the hydrogen or the oxygen on its own. So water and salt are 2 very simple and straightforward examples on how the properties and toxicity of atoms change completely depending on whether you have them alone as an element or together as a chemical compound. So, to cherry pick one type of atoms from a molecule made out of different atoms, a chemical compound, and then make claims about what this compound does based on that single type of atom is absolutely pointless. I mean, how often do you argue that salt is really dangerous because it has chlorine in it? And when have you ever tried to convince someone not to use water to put out the bonfire because the water molecules are filled with hydrogen, and hydrogen is explosive gas, and therefore it will cause an explosion? Never. Still, this is exactly what people who make claims about mercury and vaccines are doing. They're making claims about the toxicity of mercury as an element, even though there has never been pure mercury in vaccines. In the same way, there's not pure hydrogen in water, and you don't have to fear the chlorine when you put salt on your food. So, now that we have this super short introduction to chemistry and all this, we can now make a little summing up. So, one, everything is made from chemicals. And, I mean, seriously, without chemicals, it doesn't exist. So can we please just stop making this idea that we want a chemical-free world? And two, if a chemical is man-made or natural, tells you absolutely zero of whether it's dangerous or not. And three, whether or not you can pronounce the name of the chemical is completely irrelevant. And speaking of this pronouncing of chemicals, I want to talk a little bit more about fantastic chemical water, H2O, or dihydrogen monoxide. And when you say it like that, dihydrogen monoxide, it immediately sounds quite scary, maybe, and it's actually kind of hard to pronounce as well, dihydrogen monoxide. Maybe you haven't even heard of it, so let's stay away. And actually, we should even ban it, because dihydrogen monoxide actually has these properties. First of all, it's the main ingredient of acid rain. You find it in cancerous tumors. You die if you inhale it. It's used in torture, animal research, nuclear power plants, chemical warfare, and the list just goes on. And it's in baby food and beer. All of these claims about dihydrogen monoxide are true, even though it may not sound like it when we know what we're talking about. But there have actually been several episodes over the years where politicians have suggested a ban on dihydrogen monoxide. Of course, without knowing that they are trying to ban a completely normal, natural water. So the thing is that maybe we should care a little bit less about whether something could be labeled natural and just learn some basic chemistry instead. And then I have to talk a little bit about doses. As you remember from the beginning of this talk, this long list with 67 chemicals, including benzene, formaldehyde, 5 E numbers, and acetone, perhaps you want the answer to what it is. It's something I eat almost every day, and it's a completely normal egg. And just to make it clear, I mean, even though it contains benzene and E numbers and acetone and formaldehyde, does not mean that it's dangerous to get these chemicals in small amounts, small doses, that is. So to make good choices for ourselves, our health, nature, we should know some basic chemistry, and we need to understand the concept of doses. The thing is that absolutely everything is dangerous to you. It only depends on how much you need to be exposed to before it produces harmful effects. So as the father of toxicology, the Swiss physician Paracelsus put it, the dose makes the poison. And as already mentioned, even something as healthy as water is lethal if you get an overdose. That is, you drink too much of it too fast. And that, now you may think that, well, that's just a theoretically thing. I mean, no one could ever overdose on water. Well, you're wrong. I actually know a girl who almost died from drinking too much water too fast. It is dangerous when you get to the big doses. So this thing with doses, that's something you can think about next time someone's trying to say that you shouldn't have diet soda because it contains aspartame. Because yes, there is aspartame in diet soda. And yes, aspartame may be bad in really big doses. but the dose you get from drinking a soda is miles and miles and miles away from that dose level that is dangerous. An apple contains more aspartame than what you get from drinking a bottle of diet soda. So, back to nature. Really, it may be that I'm just this boring physicist, and I love nature and physics and chemistry, and I love that we can understand nature, how and why it does what it does. But I'm actually really happy that I don't have to go back to nature. We'll live in caves, and I will have 6 children before I die in childbirth from the 7th one, which is much more natural than all modern medicine, for example. So, I hope that maybe I've started to convince you that we should not using the word natural to make any kinds of claims. That would be really, really nice. So maybe we could figure out why something is good or bad for you and use that as argument, the reason why it has nothing to do with natural. That would be extremely nice. So thank you for your attention and enjoy all the chemicals.